So welcome back. So in this video we are going to learn about total station. So we have already seen different instruments, and we have performed different experiments using different instruments that we use in surveying, right? So mostly all of the instruments are more or less the manual machines, right? So first we came from we started from chain surveying, then we did compass surveying, and then we performed traversing. I mean, using we have did experiments using plane table survey, and then we did total what is it, theodolite, and then we have also seen tachometric things, tachometric relations and all. And in this video we are going to learn about the total station. So this is highly advanced machine that is used to perform all the operations that we did individually, right? So in order to calculate the chain distance, we have used what you say, first we have used chain surveying, and in order to find out the horizontal angle and vertical angles, we have taken help of theodolite to find out what you say in horizontal distance, right? Horizontal angles and vertical angles. So total station is such a type of instrument that it gives all the functions that we did manually, right? So this is we will be taking only one instrument, that is total station. It will give all the what you say, all the readings regarding the surveying. It will give the reducer level. It helps us in calculating the horizontal angles, vertical angles, and it helps us in finding the horizontal distance, vertical distance, right? So we can do all of these operations using one single instrument, that is total station, right? So we are going to learn what is total station, right? And we'll see different parts of total station, and then we'll try to figure out how we are going to find out the area electronically using this theodolite, and we'll see few of the experiments related to the total station. So side, right, this is the this is about the introduction to this total station. First yeah, we'll see the uses in particular here, right? Total station are commonly known as TS, right? It is fully automated machine. It is used for surveying, right? So generally in surveying we do measure the horizontal distance, vertical distance. We do measure horizontal, vertical angles and areas and all, right? So we'll be doing that individually. We have but certain type of instrument in accordingly, right? But total station is the only instrument which does every work that we do generally in surveying, right? So generally it will before total station, people used to calculate this horizontal, vertical angles and distance manually. But using total stations, we can take the angles and readings and area digitally, and we can plot those values which we have taken from the site directly into the CAD, and we can generate the drawings accordingly, right? So generally we used to calculate this horizontal distance, vertical distance, horizontal angles and vertical reducer level, and area topography, contours, everything we used to do manually, right? For horizontal distance, we did horizontal distance measuring by means of chain surveying, and we have also taken help of tachometry, so to calculate the horizontal distance. And coming to the vertical distance, in order to find out the vertical distance, we did with using theodolite, right? So by measuring the vertical angles, we have calculated this vertical distance using trigonometric relations. And similarly horizontal angles are calculated by using theodolite, right? And vertical angles are also calculated by means of using theodolite. And reduced level, we did this reduced level by means of auto level. By using auto level, we have calculated the reduced level. And coming to area, calculation of area and topography, area could be calculated by using what you say, chain surveying, right? So we'll be calculating the perimeter of the plot, right? Using that, we'll be drawing the area of that particular plot, right? So contouring is also done by using reduced levels. I mean reduced levels. So, and these reduced levels are calculated by using auto level, right? So we have also seen different methods of calculating reduced levels as also, right? We have also seen about auto level, and we have also tried to explain the difference between auto level and dumpy level as well, right? These are the two instruments that are used to calculate the reduced levels, right? So this is all the experiments that we have did so far. Now we are going to learn particularly about total station, which does all these operators simultaneously, right? So that is why we are going to learn about this total station, right? So it will do all these operations simultaneously. Previously we will be doing this operation individually. Now by means of total station we can do all these exercises at the same point, and simultaneously we can take all these readings, right? So this is theodolite. I think I hope you might have seen. And so this is theodolite. It is attached it is attached to the tripod, right? And we'll be having prism, right? So first we'll see the parts of this theodolite, right? So we'll be setting this theodolite on the top of this one, on top of the tripod, right? So we'll be having foot screws, right? So using these foot screws we'll adjust the level, right? So we can see the level here, and we can also see the leveling here. First will be we can do the leveling using the 3 foot screws, right? So first we'll discuss about the different components of the theodolite, right? So first we have seen what are the apparatures that we required for conducting any experiment using theodolite total station. So this is total station, and we have tripod, and we also need prism, right? So this prism, yeah, we'll see the uses of all these parameters individually, right? So this is prism. We will be bisecting the prism through the telescope, right? So this is prism, will be bisecting through the telescope, right? Now if you see the what is the components of this particular total station. So this is handle, and we have this battery locking lever, right? So we'll be setting our battery here, right? So here on this side we'll be setting the battery, and this is display unit, right? And these are clamps. These are horizontal clamps. These are used for leveling, of course, for leveling. And this is telescope, and these are this is vertical tangent screw, and this is vertical motion screw, right? So the importance of this vertical tangent screw is, if we loosen this vertical tangent screw, the setup of this telescope will rotate in the vertical direction, right? And this is horizontal tangent screw, and this is horizontal motion screw, right? So the main purpose of this horizontal tangent screw is to rotate this instrument in the horizontal direction, whereas the main purpose of vertical tangent screw is to move this telescope setup in the vertical direction, so that we can bisect the objects which is present in elevations or depression, right? So the motion screws helps us in zooming and exactly taking the values of this what you say horizontal and vertical screws, right? So for exactly bisecting the prism, we'll be making use of this horizontal motions, right? So in this is telescope, and this is eyepiece, right? So this is eyepiece, and in the backward side we'll be having the objective piece, right? Similarly in this back side we'll be having the objective piece, right? So this is used for bisecting the prism, right? So through this one we'll be first bisecting the prism, and then we'll be first we'll be seeing whether this prism is bisecting through the point or not. And once it is bisected, then we'll focus through the telescope particularly on this prism, and once the prism is bisecting through once the laser that is coming through the telescope is bisecting the exact center of this prism, so it will with respect to the motion sensor, it will directly show the readings here, right? So with respect to with respect to the objective, for what reason we are bisecting the prism, that reading will be shown. For example, if you are calculating the horizontal distance, then it will show we need to set up that in mode in horizontal distance calculating mode, then it will directly show the horizontal distance. If we need to calculate the vertical distance or height of this particular instrument, then we need to set up accordingly, and it will give the vertical distance, right? So similarly with respect to the function that we are doing, so it will give the reading, right? So these are all the typical what is the equipment sorry, components of the total station, right? So now we'll see in detail what we have, right? So this is splitting collimator, right? So this is used for bisecting the prism, and we have battery locking lever here. So we'll be taking out the batteries here. So this is this point, right? So this point is the exact center mark, right? So it is on this side. So yeah, exactly here, this is the center mark of this particular instrument, right? So we need to take the we are generally calculating the height up to the eyepiece level only, right? So that is why it is taken as the height of the instrument, right? So we'll be taking the if you are talking about the height of the instruments, it means the height is till this point, right? Till the observer eye point. And we have screws here, vertical motion screw, and we have horizontal motion screw, right? We have already seen the importance of this one. Vertical motion screw, it helps us in particularly bisecting the prism, and a vertical tangent screw, it helps us in making the movement of the telescope in vertical direction, whereas horizontal tangent screw helps us in changing the direction of this whole setup in horizontal direction in order to find out the horizontal angle or horizontal distance. While we are setting the offsets or while we are taking the stakeouts, we'll make use of this horizontal tangent screw and we'll do the operation. Whereas the horizontal clamp screw, horizontal motion clamp screw is also the similar operation with respect to the vertical motion clamp screw, right? It helps us in exactly bisecting the prism, right? So this is a display unit. In this display unit, we'll be having different function keys like F1, F2, F3, F4, and these will be numbers, right? So we'll be seeing about the display unit in the coming video, right? So this is plate level. Okay, here we can see this is the plate level, right? So he can see plate level here, and we can see the plate level here. While centering, we should ensure this bubble should be exactly coming in the center, right? So proper leveling is very much important. We are seeing this importance right starting from the theodolite, right? So this is plate level, and this is telescope eyepiece, and on this opposite side we'll be having the objective eyepiece, right? So these are all the typical components of the total station, right? So here we can see the display unit, right? So will be having different function units. So with respect to what type of operation that we are interested to go, if you are interested to calculate the area, we can use these function units and we can do the operations, right? So these are will be having numbers, right? So this key is used for marking the laser, right? So when we are setting up the instrument, right, and once we set up the instrument, in order to mark its center point, we'll be using this function of laser beam, so that the laser will come from this point, and it will directly fall on the ground, and we can mark that point as the center of this station, right? So this is used for that purpose. And so we will be having different functions here, right? So we'll be also having numbers in order to insert the coordinates, right? So this is about the display unit, and this is a display unit along with the function keys, right? So each of the instrument will be having different pattern of this one. So we'll be also having the manual with respect to whatever the instrument we are using. So we need to follow the manual and we need to check accordingly, right? So if you see the first experiment, so in this experiment, what we are doing, we are going to calculate, we are going to determine the area between four points, right? We are going to calculate the area between 4 points using total station, right? So previously we have calculated the area using chain surveying, right? We have gone through 4 of these points. We have taken the distance between all these points, and we have used method of triangulation to calculate the area, right? So we need not to go for triangulation using total station. If we are able to try by bisecting, just by means of bisecting all these points, the total station will automatically calculate the horizontals between these points, and it will directly give the area, right? So we need not to do anything. We just need to bisect all the 4 corners of the point, and using the operation, it will give the area in square meters or square in hectares or whatever the units we need, right? So first, in order to do the operation using total station, we must follow certain we must follow few points. First, we need to set up the instrument, and then we need to do the temporary adjustment, right? So the temporary adjustments are leveling and centering, right? So this leveling is very, very important. With respect to the leveling only, we'll get the results accordingly, right? So when we should do leveling properly and centering also properly, right? Total station works very, very precisely. The accuracy of the total station is 0.001 millimeters, right? So it is highly accurate instrument. So people for big projects obviously go for using this total station because of its accuracy, right? So after doing the leveling and centering, so we should ensure proper focusing adjustment. This is done for removing the parallax error. Parallax error means, so the focus eye of each of the observer will not be same, right? For example, first there is one person A who is doing the survey, and next some person B will come to do the survey, right? So imagine in that case, so the eyesight of this person and eyesight of A and B are quite different, right? So when the B is coming to operate the machine, he has to adjust with respect to his eyesight, right? So that is nothing but a parallax. He has to the removal of parallax. Focusing adjustment means removing the parallax error, right? So then we should be for example, if you are doing the area calculation part, we'll be inserting the coordinates. It means, so it will take an example of xy. So it is going to, the total station is going to represent the coordinates within this area, right? So we are generally allotting the coordinates, right? For example, x by y is for example, take 1,000 meters and 1,000 meters, right? It means it will take the area of to 1,000 meters on x-axis and 1,000 meters on y-axis, right? So it is going to show the area within this particular setup, right? So we need to set up the coordinates, and then we using the functions, right? So we will be having different modes, right? Like we'll be having area calculation, we'll be having offset calculation, right? So we'll be having stakeout calculation, we have rem function, right? So we'll be having different sort of these functions modes through which we can work, right? So we need to select area mode, and we need to bisect the points, right? Once we have selected the area mode, so it will show us to bisect the coordinates, right? So we'll be setting our instrument at this point, right? For example, wait, yeah, I'll show the figure, then we'll understand, right? So this is we have already seen the display unit. Through this display unit only, we'll be setting the function key, and we'll be setting it to the area calculation mode, right? So see, what we do is, we'll be setting our instrument at point A, right? So this is point B, we'll name it point C, D, E and F, right? So what we do is, we'll be setting our instrument at station A, and we'll be locking the coordinates, right? So then using this telescope, we'll be bisecting on point B, right? So we'll be placing our prism here, right? So this is prism. We'll be placing the prism here, and we'll bisect the prism. Okay, so this is point B, and similarly we'll place the prism at point C, and we'll place the prism at point D and point E and point F, right? So this is how we take all the readings, and after taking all the readings, we the total station will what you say, it will save the coordinates, right? Whatever the coordinates it is there, it will save, right? Once we go to the area calculation part, it will ask us to assign the coordinates, right? So then we need to assign all these coordinates, right? Like point A, B, C, D, E, and after that it will be having an option to calculate area, right? Once we press on that, it will directly going to show the area in square meters or hectares, right? So using that is how we get the area through this total station, right? So I hope you understand my explanation part, and in the field, the observer is going to explain in Telugu, and that is why I explained what he is going to do in English, right? So please show interest while he is explaining the things. He's going to explain in Telugu, but I have explained how things works, right? So first we'll be setting the instrument, and then we'll be setting the mode to the area calculation part, and then we'll be taking the coordinates values, and that is and by means of using area calculation mode, we'll be getting the area, right? So this is very simple method, but we should know the basic modes that are present in that. Once we get used to that, it will be easy, right? So this is all about the This is all about the method of calculation of area using total station.
ఫస్ట్ మనం టోటల్ స్టేషన్ సెట్టింగ్ చేసేటప్పుడు ఇది టైట్ చేసుకొని ఆన్ చేసుకోవాలి. ఆన్ చేసుకొని బబుల్ అనేది సెట్ చేసుకోవాలన్నమాట స్టాండ్తో. బబుల్ సెట్ చేసుకోగానే నాకు టిల్ట్ అనేది చూపిస్తుంది. అది ఇప్పుడు కొంచెం టిల్ట్ అనేది నేను వై అనేది, ఇవి రెండు వై అంటారు, లోపలికి ఆ బయటికి అనాలి. ఎక్స్ అనేది పైకి ఆ కిందికి అనాలి అన్నమాట. ఇప్పుడు నేను వై సెట్ చేస్తాను. వై ఎక్కువ ఉంది కాబట్టి వై తగ్గించాలి. వై తగ్గించాను నేను. ఇప్పుడు ఎక్స్ తగ్గించాలి. ఎక్స్ తగ్గించాను. ఇట్లా మనం సెట్ చేసుకోవాలన్నమాట. సెట్ చేసుకొని అంటే మనకి దగ్గరలో ఇక్కడ పైలింగ్ అనేది జరుగుతుంది. దానివల్ల ఏంటంటే గ్రౌండ్ అనేది డిస్టర్బ్గా ఉంది బాగా. ఓకే, ఇట్లా చేసుకొని ఓకే చేసుకోవాలి మనం. ఓకే చేసుకున్నాక మనం నెక్స్ట్ వర్క్ ఏంటంటే మెనూ
తోటి ఆపరేషన్ చేయాలంటే
మెనూస్లోకి వెళ్ళిపోయి కోఆర్డినేట్స్లో స్టేషన్ సెట్ చేసుకోవాలంటే మనం చెప్పాను కిందక అట్లా స్టేషన్స్ సెట్ చేసుకొని వర్క్ చేసుకుంటాం అన్నమాట. నెక్స్ట్ వచ్చేసి ఇప్పుడు మనకి టాప్ కాన్లో ఇది హారిజంటల్ ఉంది కదా, ఇది హారిజంటల్ రొటేట్ అవుతుంది కదా. అదే మనం ఈ లాక్ కనుక వేస్తే హారిజంటల్ రొటేట్ కాదు, ఇది స్లో మోషన్లో మనం ఏదైనా టార్గెట్ చూడాలంటే లాక్ వేసుకొని చూడాలి. ఇది అనేది వెర్టికల్ తిరుగుతుంది కదా ఫ్రీగా. ఇది వెర్టికల్ లాక్ అనేది లేస్తాం. ఇది ఇంకా మూవ్ అవ్వదు. ఇది ఏంటంటే టార్గెట్ మీద పెట్టుకొని ఏదైనా ఒక టార్గెట్ని చూసుకొని దాని మీద లాక్ చేసుకొని స్లో మోషన్లో ఆ టార్గెట్ని మెజర్ చేస్తాం అన్నమాట. దీనివల్ల వెర్టికల్ లాక్. ఇది జూమింగ్, ఇది ఏదైనా టార్గెట్ని జూమ్ చేయడానికి మనం ఇది జూమ్ చేస్తూ ఉంటాం అన్నమాట. ఇది టోటల్ స్టేషన్ టాప్ కాన్. ఇప్పుడు ప్రిజం తీసు మనకి ప్రిజం అనేది 1.3 నుంచి 2.15 దాకా ఉంటుంది. ఇది 1.3 ప్రిజం. ఇప్పుడు ప్రిజం సెట్ చేశాక దాని సెంటర్కి 1.3 ఉంటుంది. ప్రిజం ఇది మనకి హైట్ పెంచుకోవాలంటే ఇట్లాగా 2.15 దాకా ఉంటుంది. 2.15 దాకా మనం లాక్ చేసుకొని దీని నుంచి టార్గెట్ పెట్టుకొని వెళ్ళచ్చు. స్టేక్అవుట్. ఇది ప్రిజం. దీని కాన్స్టెంట్ -30. టాప్ కాన్ ప్రిజం అన్నమాట. ఇవి ప్రిజం అంటారు. మనం దీని మీద టార్గెట్ చేస్తాం. దీని సెంటర్లో అనేది వైర్లు ఉన్నాయి కదా, దీనికి మనం టార్గెట్ చేయాలి. కరెక్ట్గా సెంటర్లో పెట్టి ఇన్స్ట్రుమెంట్ టార్గెట్ చేయడం వల్ల దీంతో డిస్టెన్స్ అనేవి మనకి వస్తూ ఉంటాయి. టోటల్ డిస్టెన్స్లో కోఆర్డినేట్స్ డిస్టెన్స్ ఏది చూసినా కానీ ఈ టార్గెటే వాడతాం మనం. దీని నుంచే రిఫ్లెక్ట్ అయ్యి దీనికి వాల్యూస్ అనేవి వస్తాయి. మనం ఇన్స్ట్రుమెంట్ సెట్ చేసామన్నమాట. సెట్ చేసినప్పుడు అనేది ఈ బబుల్ అనేది సెంటర్లో ఉండాలా. బబుల్ అనేది సెంటర్లో ఉండాలన్నమాట. మనకి సెంటర్లో ఉన్నాక సెట్ చేసుకున్నాక ఆన్ చేసుకోవాలి ఇన్స్ట్రుమెంట్ని. ఇది టాప్ కాన్. ఇది ES105 మోడల్ అన్నమాట. ఇప్పుడు ఇందులో మనకి ఫస్ట్గా టిల్ట్ సెట్ చేసుకోవాలి. మనం ఇక్కడ టిల్ట్ అనే ఆప్షన్ ఉంటుంది F2లో. ఈ టిల్ట్ అనే ఆప్షన్ ప్రెస్ చేసి టిల్ట్ సెట్ చేసుకోవాలి. ఇది 0 చేసుకోవాలన్నమాట. టిల్ట్స్ ఆప్షన్ అయిపోయాక మెనూలోకి వెళ్ళి ఫంక్షన్స్లో ఇప్పుడు కోఆర్డినేట్స్ ఉన్నాయి. దీన్ని ఓరియంటేషన్ చేసుకోవచ్చు. ఓరియంటేషన్ అంటే మనకి ఇక కోఆర్డినేట్స్ లేవు కాబట్టి మనం ఇప్పుడు 10,000 ఇచ్చాము. ఈస్టింగ్, నార్తింగ్ 1,000 to 2,000 ఇచ్చుకున్నాం. ఏరియా చిన్నది కాబట్టి 1,000 2,000 ఇచ్చుకున్నాం. హైట్ అనేది 100 ఇచ్చుకుందాం. ఇది ఇన్స్ట్రుమెంట్ హైట్ ఇక్కడ దాకా మెజర్ చేసుకోవాలి. కింద పాయింట్ నుంచి ఇక్కడ దాకా మెజర్ చేసుకుంటాం. ఇన్స్ట్రుమెంట్ హైట్ అనేది చేసుకొని ఇక్కడ ఇన్పుట్ చేస్తాం అన్నమాట. ఇన్స్ట్రుమెంట్ హైట్ సపోజ్ 1.4 ఉంది, 4 to 5 ఇన్స్ట్రుమెంట్ హైట్ మెజర్ చేసుకొని బ్యాక్ సైడ్ ఎన్ఈజెడ్ ఉంటే కోఆర్డినేట్స్లోకి వెళ్ళాలి. మన దగ్గర కోఆర్డినేట్స్ లేవు కాబట్టి బ్యాక్ సైడ్ యాంగిల్స్లోకి వెళ్తాం అన్నమాట. యాంగిల్లోకి వెళ్ళి నార్త్ ఉంటుంది కదా, ఇప్పుడు సపోజ్ మన నార్త్ ఇటు పక్క ఉంది. ఇప్పుడు నార్త్ అనేది మనం 0 చేసుకోవాలి. నార్త్కి ఇన్స్ట్రుమెంట్ మూవ్ చేసుకొని 0 అని పెట్టి నార్త్ 0 రికార్డ్ చేసుకోవాలి. ఇప్పుడు మనకు కార్నర్స్ వచ్చినాయి. ఈస్టింగ్ ఎలాగే ఉంటుంది, నార్తింగ్లో 2 meters వెళ్ళింది కాబట్టి నార్తింగ్ పెరుగుతుంది అన్నమాట. 2002 meters అని వస్తుంది అన్నమాట హైట్. ఇది మనం 0 పెట్టాం, నాన్ ప్రిజం మోడ్లో పెట్టాం కాబట్టి ప్రిజం పెట్టుకునే అవసరం లేదు. అక్కడ ఇక్కడ పాయింటెడ్ 1 అని పెట్టేసి, లేకపోతే దీని స్టేషన్ ఏదైతే ఉందో అది పెట్టేసుకుంటాం. నార్త్ పాయింట్ అనుకో, ఇది నార్త్ పాయింట్ కింద సేవ్ చేసుకుంటాం. దీన్ని మారుతుంది, దీని ద్వారా నార్త్ అని సేవ్ చేసుకొని పాయింటెడ్ 1లో దీన్ని అనేది రికార్డ్ చేసుకోవడం జరుగుతుంది. రికార్డ్ చేసుకుంటే రికార్డ్ అయిపోయింది. ఇప్పుడు ఆటోమేటిక్ పాయింటెడ్ అనేది చేంజ్ అవుతుంది. అంటే 1లో నార్త్ రికార్డ్ అయిపోయింది, బాగా 2 నుండి కంటిన్యూ చేసుకోవచ్చు సర్వే అన్నమాట. ఇప్పుడు సర్వే రిఫరెన్స్ తీసుకోవాలన్నమాట. ఇంకా దీని పాయింట్ నుంచి మనం అనేది నెక్స్ట్ ఒక పాయింట్ పెట్టుకుంటూ అలా ట్రావర్సింగ్ అనేది చేసుకుంటుంటాం. నెక్స్ట్ ఒక సిపి పెట్టుకుంటాం. సపోజ్ చిన్న ప్రజెంట్ తీసుకో, రాయి మీద పెట్టు, ఏదైనా రాయి మీద. సపోజ్ ఒక పాయింట్ అనేది మనం పెడుతున్నాము. పెట్టినప్పుడు దాన్ని టార్గెట్ చేసి దీన్ని టార్గెట్ చేసుకోవాలన్నమాట. పాయింట్ రాడ్ హైట్ వచ్చి 1.1 ఉంది, 0.1 ఉంటుంది. దాని హైట్ వచ్చి 0.1 ఉంటుంది. 0.1 మెజర్ చేసుకొని ప్రిజం మోడ్ మారుతుంది అన్నమాట. ప్రిజం మోడ్ చేసుకొని మెజర్ చేసుకోవాలి. మెజర్ చేసుకునే వెంటనే దాని కోఆర్డినేట్స్ అనేవి మనకు వస్తాయి. సపోజ్ ఇది S1 అనుకోండి, ఫస్ట్ పాయింట్ S1 స్టేషన్. కాకపోతే N అయిపోయింది కాబట్టి N1 అని పెట్టుకున్నాను. పాయింటెడ్ 2లో రికార్డ్ అయింది, అది రికార్డ్ అయిపోయింది అన్నమాట. సపోజ్ ఇప్పుడు ఒక పాయింట్ మనకు స్టేషన్ వచ్చేసింది, నెక్స్ట్ స్టేషన్కి వెళ్ళాలి. ఇంకొక పాయింట్ పెట్టు, ఇట్రా అటు పెట్టు, రోడ్డు మీద ఎక్కడైనా. చాలు. ఇప్పుడు సెకండ్ పాయింట్ అనేది మనం N2 టార్గెట్ చేసుకొని మెజర్ చేసుకున్నాం. N2 కూడా కోఆర్డినేట్స్ వచ్చినాయి, రికార్డ్ చేసుకున్నాం. పాయింటెడ్ 4 ప్రతిదీ పాయింటెడ్ మాట్లాడుతుంది. ఇప్పుడు సపోజ్ దీని నుంచి పాయింట్ డిస్టెన్స్ కావాలి మనకి. డిస్టెన్స్ కావాలంటే దీంట్లో మనకి డిస్టెన్స్ కూడా షో అవుతుంది. హెచ్డి అంటే హారిజంటల్ డిస్టెన్స్, ఇక్కడ నుంచి 12 meter హారిజంటల్ డిస్టెన్స్ ఉంది. జెడ్ఈ అంటే వెర్టికల్ యాంగిల్. హారిజంటల్ యాంగిల్ మనం 0 చేసాం కదా, ఇటు సైడ్ అనేది 0 చేసాం. ఇక్కడ నుంచి యాంగిల్ అనేది తిరిగి 139 degreesకి వెళ్ళింది అన్నమాట. 139 degrees 28 minutes 31 seconds మన యాంగిల్ అన్నమాట అది. ఇప్పుడు మనకి సెకండ్ పాయింట్ కూడా అయిపోయింది. సపోజ్ ఇప్పుడు మనం థర్డ్ పాయింట్కి వచ్చాం. మళ్ళీ ఓరియంటేషన్కి వెళ్ళి డైరెక్ట్ అబ్జర్వేషన్కి వెళ్ళి థర్డ్ పాయింట్కి రా, ఇక్కడికి రా. థర్డ్ పాయింట్ అనేది మనం మెజర్ చేసుకున్నాం. థర్డ్ పాయింట్ మెజర్ చేసుకున్నాం అన్నమాట. ఇప్పుడు ఇది N3 కోడ్స్ వేసుకోవాలన్నమాట. మనం డ్రాయింగ్లో ఆటోకాడ్లో దీన్ని ప్లాట్ చేసినప్పుడు దీని కోడ్స్ వస్తాయి, దాని నుంచి ఫైండ్ అవుట్ చేయొచ్చు ఏ పాయింట్ ఎక్కడ ఉందనేది. పాయింటెడ్ మారింది, 5 వచ్చింది. ఓకే, ఇప్పుడు మనం దీని ఏరియాని తీయాలి. ఏరియా క్యాలిక్యులేషన్ చేసేటప్పుడు దీని ఏరియా తీయాలనుకోండి, ఇందులో ఒక ఆప్షన్ ఉంటుంది ఏరియా క్యాలిక్యులేషన్ అని. సపోజ్ ఇది ఏరియా క్యాలిక్యులేషన్లోకి వెళ్ళి లేకపోతే ఏరియా క్యాలిక్యులేషన్ మనం ఆల్రెడీ పాయింట్ మెజర్ చేసి ఉన్నాం కాబట్టి లోడ్స్లోకి వెళ్ళి ఫస్ట్, సెకండ్, థర్డ్, ఫోర్త్. ఫస్ట్ పాయింట్ ఏంటి, ఎండ్ పాయింట్ కదా మంది, దీనికి ఎంటర్ చేసుకోవాలి. సెకండ్ పాయింట్ ఇది మనకి N2 అక్కడ తీసుకున్నాము. ఓకే, థర్డ్ పాయింట్ ఏంటి మంది, ఇది ఫోర్త్ పాయింట్, ఫోర్త్ దీనివల్ల ఏంటంటే మనకు ఒక బౌండరీ క్రియేట్ అయింది, బౌండరీ క్రియేట్ అయింది. దీన్ని క్యాలిక్యులేట్ చేసినప్పుడు ఈ బౌండరీ యొక్క స్క్వేర్ మీటర్స్ అనేది ఇక్కడికి వస్తుంది అనమాట. 62.943 స్క్వేర్ మీటర్స్ వచ్చింది ఏరియా.
దీని ఏరియా 4
పాయింట్ ఏరియా అన్నమాట. ఇది ఏరియా మనం ఇలా ఫైండ్ అవుట్ చేయొచ్చు అన్నమాట. ఇది ఏరియా క్యాలిక్యులేషన్స్ అన్నమాట.
Welcome back. So in this video we are going to see how we are going to calculate the height of a height using the remote elevation method, right? So remote elevation method is one such mode that is coming along with the total station. So previously we have seen how we are going to calculate the area, and now we are going to see how we are going to calculate the vertical distance, right? So first we'll be setting our instrument to total station, and we'll be performing the temporary adjustments, right? So we have already seen this. First we'll be setting our instrument of total station, and then we'll be doing the temporary adjustments. In temporary adjustments we'll be having leveling and centering, and then after we'll be having the focusing adjustment, that is removing the parallax, right? So then after we'll be by means of using function keys, and we'll be having different modes through which we can work with the telescope with this total station, right? So in this one, in this video, as we are going to calculate the elevation, right? So what we are going to calculate is we are going to calculate the elevation using this total station. So in order to find out this elevation, we have to select this REM mode, right? REM is nothing but remote elevation method, right? So after setting that one, so after setting that, we are going to calculate the vertical distance, right? So first we'll see the theoretical point. So this is our total station. We'll be setting at at point A, and we are interested to calculate the vertical distance between point B and B dash, right? For example, imagine in our field case there is a pole. This is a electrical pole, and we have to calculate the exact height of this electrical pole, right? So whatever could be the purpose for calculating the vertical distance, right? So we are more interested to calculate the vertical distance, right? So generally people do calculate the vertical distance. For example, if you are setting the alignment of roads, right? So in order to, if you are laying a fresh road, right? So we don't know the exact exact nature or exact topography of this road, right? So we don't have any idea about what are the different features that are available on this road, right? So first of all, what we do is, before constructing the roads, we'll be taking this total station, and we'll be going to the field, and we'll be marking different arbitrary benchmarks, right? So these are different arbitrary benchmarks. Will be marking the benchmarks, right? So in order to calculate the exact height of this pole, we'll be using this REM method, remote elevation method. So we'll be calculating the exact height. So with respect to that exact height and position, we can assign the center line in future, right? We can assign the center line in future, right? So that is one such basic importance. And the typically see, whatever the points that are included while we are learning about the measurement of vertical distance, the same points applicable here, right? So we are not learning anything new. We are just using one such another instrument, that is total station, to find out all the different variables that we used to calculate individually before having this total station, right? So coming to the point, so what we do is, after setting the instrument at station A, right, we'll be setting our taking our prism, which is we'll be placing first at this point, right? So through that we'll get the height of this particular instrument, right? And in the field, the instructor is going to take a prism, only this prism, right? He is not taking the stand. So what he is going to do is, he is going to place the helper is going to place the prism exactly on the ground level, and he know the exact height of this prism is 0.1 meters, right? That means it is 10 centimeters, right? So he will be noting the total station will be knowing the initial reading that as the 10 centimeters, right, or 0.1 meters, right? So after this one, so by means of using vertical tangent screw, so the instructor will bisect the exact what is a wire or exact elevation up to which we are required to calculate the vertical distance, right? So once he is able to bisect, the total station will automatically show the vertical distance with respect to the amount of angle that it has tilted. The total station has an inbuilt mechanism with respect to the amount of angle it has been tilted. It will show the reading, right? So initially it is set up to 0.1 meters, and when we are tilting the telescope, it will the more will be the tilting, the more will be the vertical distance, right? So that is how we get that is how the total station is going to show the what is the exact vertical distance, right? So this is nothing but remote elevation method. Remote elevation method means we are not physically calculating the vertical distance. We are taking help of this what is a total station to calculate this vertical distance remotely. It means there is no we are not doing it by means of measuring tape or anything. That is why this method is called as remote elevation method, right? So this is about the theoretical point of how we are going to calculate the vertical distance using remote elevation method. The observer will be showing how he is going to, first he'll be setting the instrument, and then he'll be taking help of the helper, and the helper is going to place exactly at the ground level through which we are interested to calculate the vertical distance, right? So again, the instructor will bisect the top point, and the vertical distance is shown in the telescope total station, right? So this is about the REM method. Now we'll see the another method of doing how we are going to set up the offsets, and how we'll see what is stakeout and what is the importance of stakeout, and how we are going to take out the stakeouts using the total station.
క్యాలిక్యులేషన్స్ మాట. సపోజ్ మనం ఇప్పుడు అక్కడ హై టెన్షన్ వైర్ వెళ్తుంది, కరెంట్ వైర్స్. ఇది ఏ హైట్లో ఉంది తెలుసుకోవడానికి, రోడ్ హైట్ నుంచి ఏ హైట్లో ఉంది తెలుసుకోవాలనుకోండి. మనం సపోజ్ వాడు అక్కడ టార్గెట్ పెట్టుకున్నాడు, కరెక్ట్ దాని కిందే పట్టుకుంటే ఎగ్జాక్ట్గా ఉంటుంది అన్నమాట. పట్టుకున్నాడు, దానికి మనం ఆర్ఈఎం రిమోట్ ఎలివేషన్ మెథడ్ ఉంది కదా, ఈ మెథడ్ని వాడతాం అన్నమాట. ఆర్ఈఎం చేసుకొని ఫస్ట్ దాన్ని మెజర్ చేసుకోవాలి. టార్గెట్ని మెజర్ చేస్తాం. టార్గెట్ని మెజర్ చేశాక హైట్ ఆఫ్ రాడ్ హెచ్ఆర్, హైట్ ఆఫ్ రాడ్ దాన్ని 0.1 అనమాట. 0.1లోనే ఉంది, ఓకే చేసాము. ఇప్పుడు ఆర్ఈఎం అనే ఆప్షన్ నొక్కాము. హెచ్టీ అనేది 0.1 ఉంది గ్రౌండ్ హైట్ నుంచి, దాని హైట్ 0.1లో ఉంది. ఇప్పుడు వెర్టికల్ యాంగిల్ మనం మూవ్ చేసుకుంటే హైట్ పెరుగుతుంది కదా, ఇందులో చూడండి ఇది హైట్ పెరుగుతుంది కదా. ఇట్లా మనం తీసుకెళ్ళి సపోజ్ బ్లాక్ వైర్ వెళ్తుంది కదా, హై టెన్షన్ లైన్ అనుకోండి, దాంట్లో పెట్టుకుంటాం. కరెంట్ లైన్ ఏదైనా సపోజ్ కింద నుంచి ఆ లైన్ అనేది మనకి 4.955 మీటర్స్లో ఉందన్నమాట. అంటే దగ్గరగా 5 మీటర్స్లో మనకి కింద గ్రౌండ్ లెవెల్ నుంచి 5 మీటర్స్లో ఉంది. అది మన హెచ్డి అంతా ఇక్కడ నుంచి ఆ పాయింట్ ఎంతలో ఉంది, 10 మీటర్స్లో ఉంది. ఆటోమేటిక్గా వచ్చేస్తుంది. అది పాయింట్ మనకి 10 మీటర్స్లో ఉంది డిస్టెన్స్లో. హైట్లో వచ్చేసి 5 మీటర్స్లో ఉంది, 4.955 మాట. స్టాప్ అయిపోతుంది. దీన్ని రికార్డ్ చేసుకోవచ్చు మనం. ఇది వచ్చి ఏరియా క్యాలిక్యులేషన్, రిమోట్ హైట్ ఎలివేషన్, ట్రావర్సింగ్. అప్పుడు 4 పాయింట్లు ఉన్నాయి కదా, ఇదే 4 పాయింట్లు మనం ట్రావర్సింగ్ చేసుకుంటూ వెళ్ళి మళ్ళీ మనం తిరిగి వచ్చి ఇదే పాయింట్కి వచ్చినప్పుడు మనకి సేమ్ కోర్నర్స్ 1000, 2000, 100 రావాలి. అవి రావు, కొంచెం ఎర్రర్ అనేది వస్తుంది కాబట్టి, ఇన్స్ట్రుమెంట్ ఎర్రర్, వెదర్ ఎర్రర్ ఉంటుంది కాబట్టి వస్తుంది. మనం దాన్ని డిస్ట్రిబ్యూట్ చేసుకోవాలి, అన్ని పాయింట్కి డిస్ట్రిబ్యూట్ చేసుకోవాలి. ఎన్ని పాయింట్స్ ఉంటే అన్ని పాయింట్ డిస్ట్రిబ్యూట్ చేసుకోవాలి, క్లోజ్ ట్రావర్సింగ్ చేసుకోవాలి మరి.
So welcome back. Welcome to another experiment using total station. So in this video we are going to see stakeout using total station, right? First of all, we'll see what is this stakeout and how we are going to set up this stakeout using total station, right? So stakeout is nothing but finding a specific point in the field, right? So previously we have did this stakeout using what you say plane table surveying as well, right? So in plane table survey, what we did is in one such method, right? In plane table we have did interaction method, traversing method, and radiation method, right? And resection method, right? So we have also seen the importance of all these methods individually. So I'm talking more interested about the resection method, right? In resection method of plane table surveying, what we did is previously on one particular day we used to have we have located two different points in the field, and on the same day there is a rain that has fallen, and this point has been vanished, right? So using the method of resection, what we did is we have found that particular point which is lost in the field, right? So we used a method of resection. It means we have I think we have already seen what is method of resection, right? So we did method of resections in order to calculate the lost point, that is lost point or missing point by means of any particular reason, right? So we did a resection. As resection is a physical method through which we calculated the lost point, right? So now in order to find the lost point, while we are doing the surveying using a total station, so if we are lost any point, and if we know the coordinates of that particular point, and we are supposed to locate that particular point in the field, right? So we have a plot of something like this. So we are missing with this particular point, right? We don't know exact position of this particular point. So no, that is why we are taking help of this total station, and stakeout is one such mode that helps us in finding the exact position of this stakeout, exact position of this particular point, right? So in order to before doing the stakeout operation, we know there is a usual operation that has to be performed before actually going to the experimental procedure, right? First we need to do the setting up total station, and then we need to do the temporary adjustments, right? So these are very important with respect to every experiment that we do, right? So the one should, the instructor or the one who is doing the survey has to ensure all these points. Then only the results which we are obtaining will be accurate with respect to the level of accuracy which we are performing while doing the centering and leveling only, right? So, and also the accuracy basically depends upon the another person who is carrying the prism, right? If the prism, if he is placing the prism in the exact position, okay, while placing the prism also he should ensure the centering of the prism every point, right? There will be a leveling upon the prism point also. So after placing at every point, and if you are before taking the readings, the one who is carrying the prism has to ensure it is centered centered very levelly. So the leveling should be accurate. If it is if there is a small tilt, that it will result in the less accuracy of the particular work, right? So in order to increase the accuracy or the efficiency of work, the instrument should be leveled very accurately, right? So, and focusing adjustments also, I mean we need to remove the parallax error as well, right? So in the function, what is the display unit, will be having one such mode, right? We have seen we'll be having different modes like calculation of area, offsets, calculations, and one such and also we'll be having about the stakeouts, right? So we need to select that stakeouts, and we need to, after taking that, it will be having the exact coordinates of that particular lost point, right? So after entering the exact coordinates of that particular point, so it will show us to the instructor will move towards that particular point. So and it will once the instrument is sighting the exact prism here, right? With respect to the instruments, if it is placed exactly at the last point, so it will show no error, right? So if it is placed before or in backward or in any direction, right? So the instructor will tell the other person to move accordingly, right? So if it is in left position, so with respect to that he will adjust, and he will bring the exact mark, and he can see that exact mark with respect to the coordinates which he has assigned, right? So if the coordinates that he has assigned and the coordinates that it is falling on that field, if those two are matching, then it indicates that the instructor has located the exact lost point, right? So this is about the stakeout, right? Stakeout is nothing but the finding the specific point in a field, right? So in these stakeouts also, again we have different methods, right? I mean every time it is not possible to have the exact horizontal distance. Sometimes we may also have the what is a polar, I mean curvy nature, right? And also we'll be taking help of horizontal directions, we'll be having a vertical direction, and also we can make use of coordinates, right? So we are now talking about this method of coordinates only. So using coordinates we are going to set up the offsets, right? So apart from coordinates also, we can place the exact stakeouts using means of orthogonal method. So this is what we are talking, this is Cartesian mode. So in this quotational mode, we'll be having the exact coordinates of x and y. So using that, we'll be placing the exact position of the point, right? So if the point is in some say here it is in curvy point, right? So we are interested to find out this particular point, right? So if it is in a curvy nature, so we'll be making use of this polar mode, which is already there in the function key, right? So if it is in exactly in horizontal distance, so we can make use of this orthogonal mode. And if we have the Cartesian modes, like if we have the coordinates of x and y, then we'll make use of this particular mode, right? With respect to the field condition, we are going to select the particular stake mode, right? So this is all about the stakeout, and this is basically importance of stakeout, and this is the theoretical point. So in practical point, the observer will be inserting the initial coordinates, right? So initial coordinates and the horizontal distance between the point, right? So what happens is, so he know the exact horizontal distance and he know the coordinates, right? So he'll be telling the helper to move to that particular point, and as he know the coordinates and the height, exact horizontal distance. So with respect to this prism, right, if he is moving in backward direction, it will show the reading, right? In video, so it is exactly around 7.1 or 7.2 meters. Okay, so with respect to that only, it will show the horizontal distance, right? As the total station has the capacity to calculate the horizontal distance, and we know the exact horizontal distance between our last point and our station. So it makes us very easy to calculate the exact last point, right? So this is about the stakeouts. I hope you made it clear. And once we see the field part, you will get to understand what I am talking exactly, right? So thank you.
అప్పుడు మనం స్టేక్అవుట్, ఇప్పుడు నేను సపోజు ఎస్ఓలోకి వెళ్ళి స్టేక్అవుట్స్ చేస్తున్నాను అన్నమాట. స్టేక్అవుట్స్లో నాకు ఏ పాయింట్ కావాలి, N1 కావాలి. అంటే నేను వేసాను ఒక పాయింట్ N1, ఇక్కడ పాయింట్ లేదు, అది గ్రౌండ్లో పట్టుకున్నారు. సేమ్ అదే పాయింట్ మళ్ళీ లొకేట్ చేయాలంటే N1 కోఆర్డినేట్స్ వచ్చినాయి, కోఆర్డినేట్స్ ఇన్పుట్ చేసుకొని ఓకే చేసా అంటే ఇది నాకు ఆ పాయింట్ మీదకి వెళ్ళడానికి చూపెడుతుంది అన్నమాట. ఈ యాంగిల్ అనేది ఇట్లా తిప్పి దీన్ని 0 చేసామనుకో ఆ పాయింట్కి లొకేట్ అవుతుంది. దీన్ని స్టేక్అవుట్స్ అంటారు అన్నమాట. చూసారా, నేను N1 అనేది దానికి వెళ్తున్నా. ఓకే, యాంగిల్ 0 అయిపోయింది N1 సైడ్. అట్రాలాక్స్ అంటున్నాడు. డిస్టెన్స్ అనేది ఇక్కడ నుంచి 7 మీటర్స్ చూపెడుతుంది నాకు. 7 మీటర్స్ అనేది చూపెడుతుంది పాయింట్కి. పట్టుకో, ఇందాక అతను N1 పాయింట్ ఎక్కడ పెట్టాడో కొంచెం ఇలా దూరం నుంచి చూపిస్తుంది. లైట్ ఇట్రానా, ఇట్రా. అలా యాంగిల్లో సెట్ చేసుకున్నాక, టార్గెట్ని మనం అబ్జర్వేషన్ అనేది మెజర్ అనేది చేయాలి. మెజర్ అనేది చేశాక ఫోర్ ఎంఎం మనకు ఆ పాయింట్ అనేది 4 mm లొకేట్ అయిపోయింది. అదే తను 1 మీటర్ అనుకుంటే 1 మీటర్ అనుకున్నాడని చెప్తుంది అన్నమాట. మనకి 4 mm ఆ పాయింట్ అనేది లొకేట్ అయిపోయింది. ఇట్లా మనం స్టేక్అవుట్ చేసుకోవచ్చు. ఏదైనా మన పాయింట్స్ని మళ్ళీ మనం అక్కడ పోతే కోఆర్డినేట్స్ మన దగ్గర ఉంటే, బెంచ్ మార్క్స్ ఉంటే వేరే పాయింట్ మనం లొకేట్ చేసుకోవచ్చు. దాన్ని ఎస్ఓ అంటారు, స్టేక్అవుట్స్ అంటారు.
So welcome back. So in this video, we are going to see another experiment using total station. So we are going to set up offsets using total station, right? So before going to the experimental point, we'll understand what is offset and why it is important, and how we are going to do the operation using total station, right? So offset is nothing but offset is a method of measuring the distance and angles between 2 points on the ground, right? So this for example, so we are constructing a roads, and we are in order to construct the road, we'll be laying the center line, right? That is nothing but alignment, right? So we know the exact boundaries of this road, right? So with respect to this road, we'll be setting the offsets, right? So for example, if the center line is at a distance of 1.75 meters, right? So we know the exact boundary, we know this exact boundary line, So using a total station, we are going to mark this center line exactly at every 1.75 meters, right? So what we are doing, we are measuring the horizontal, we are placing the distance, right? Right. So we are placing the or marking the distance along this center line, right? So I mean, so the method of measuring the distance or angles, right, is nothing but the offsets, right? So the offsets are very we generally come across these offsets while marking roads, or in order to in order to lay any particular railway lines or anything. So we generally come across these offsets, right? So first, before setting the instruments, we should ensure all these points for setting up the total station temporary adjustments like leveling and centering, and after that we need to focus, that is just by we need to remove the parallax error, and then we need to select the offset mode along with area mode, REM mode, and stakeout mode. We will be also having the offset mode in the total station. So using the function keys, we need to go into this offset mode, and we need to select the offset mode, right? So again, in this offset mode also, there were three different modes through which we can work with the total station, right? So first we'll be having the distance offset method. It means, so we know the distance, so we know this exact, we are on this line, and we are supposed to calculate, we are supposed to mark the offset at particular known distance, right? So we know this distance, right? So this is known distance, so we are going to mark the exact horizontal distance from this known distance, right? We know this exact d2 distance, so we'll be making use of a total station. So we'll bisect through this point first, right? And of using the horizontal tangent screws, we'll be bisecting we'll be bisecting on the prism, right? So initially the what you say the follower will be placing the prism at this point, which is exactly on the surface on this line, right? Again, what you say, the follower will be moving towards this point, and for example, if we are supposed to mark the exactly 5 meters, right? So when the follower is coming exactly at the 5 meters, the instructor who is bisecting the prism, he can able to see that the distance traveled from point A to B is 5 meters, right? If it is exactly 5 meters, then he will then he will assign the follower to mark that particular point as the 5 meters from exact line, right? So this is how we going to take the offset using the distance, right? So in set point means, set points is also quite similar to the distance offset method, right? Previously we know the exactly d2 distance, right? So now what we are going to do is, we'll be setting again the instructor who is telling the what you say follower to go to this exactly same plane, some x place, right? So we know the exact distance. So he can able to calculate the distance using a chain or tape, right? So he can ensure that particular distance, and the instructor who is seeing or who is bisecting the prism also confirms that distance as the exact distance, right? So if he is measured so it brings a coordination, what you say, it brings the coordination between both the instructor and the follower, right? So similarly, we'll be having the plane offsets as well, right? So these are three different methods of offsets, right? So first, offset is nothing but setting the distance or angle on the ground surface, right? So we'll be doing three of these we'll be having three different modes of calculating the setting the offsets, right? So offsets are generally important in while fixing the alignment of the road, right? So as I was talking earlier, so we know the exact this is the total width of the road. For example, if it is single lane, it will be 3.75 meters, right? So we know the exact boundary. From this point, we need to set up exactly at 3.75 by 2, right? So we know this exactly horizontal distance. So we'll be setting our instrument at a station, one particular station, and we know this exactly. First, the follower will be coming and he will be placing the prism here, right? So what you say, the instructor will bisect this point, and he will mark this particular point as a 0 meters, right? So again, by means of using horizontal tangent screws, he will bisect the after fixing this particular point, the follower will come to the come this way, right? So he will assign the instructor will what is a coordinate by means of signaling. He will tell whether to move on left or right direction, right? Till he can able to see this distance as 1.7 to 5 meters, right? So he will assign the follower that it is, if it is reaching 1.7 to 5 meters, so he will assign him to mark that particular point as the exact what is a center line of this particular road, right? So this is the major importance of using the total station, right? So this is about the theoretical point of view. And you can see the you can see the what is it you can see the practical point where the observer and fielder observer and instructor are working, right?
ఆఫ్సెట్స్ ఉన్నాయి. ఆఫ్సెట్స్లో మనం ఫస్ట్ పాయింట్ అనేది N1 ఓకే ఓకే చేస్తున్నాను. సెకండ్ పాయింట్ అనేది N2 ఓకే. పాయింట్కి 8.5 మీటర్స్ చూపెడుతుంది. ఇది N1కి N2కి 8.52 మీటర్స్. దీన్ని ఓకే చేసుకొని సేమ్ నేను ఇప్పుడు లైన్లో అదే లైన్లో నాకు 3 మీటర్స్లో పాయింట్ కావాలి. సేమ్ లైన్లో 3 మీటర్స్కి పాయింట్ కావాలంటే 3 మీటర్ క్యాలిక్యులేట్ చేసి కోఆర్డినేట్స్ ఇచ్చేసింది. ఇప్పుడు ఇది కోఆర్డినేట్స్ నేను లొకేట్ చేయాలి సైట్లో. దీనికి ఎస్ఓ ఆప్షన్ టైప్ చేయగల ఎస్ఓలో వచ్చింది. ఇప్పుడు సేమ్ నేను ఈ పాయింట్ని లొకేట్ చేస్తాను అనమాట.
3 మీటర్స్ వరకు అదే చూపిస్తుంది అన్న దీంట్లో.
ఇప్పుడు మనకి ఈ లెంత్లో లైన్ 8 మీటర్స్ లైన్ ఉంది. మనం అదే లైన్లో ఎన్ని మీటర్కి ఆఫ్ సైడ్ కొట్టుకుంటామో అన్ని మీటర్కి పాయింట్ అనేది చూపిస్తుంది అన్నమాట. ఇట్లా ఇప్పుడు మనకి అక్కడి నుంచి 3 మీటర్స్లో పాయింట్ పట్టుకోరా. కానీ 3 మీటర్స్
అప్రాక్సిమేట్గా మెజర్ చేసిన డిస్టెన్స్ అన్నట్టు
3 మీటర్స్లో సేమ్ లైన్లో మనకి పాయింట్ అనేది లొకేట్ అవుతుంది. ఇటు పట్టుకో. ఇట్లా మనం ఆ పాయింట్ని లొకేట్ చేసుకుంటాం. అట్లాగా ఏదైతే అది మనకి 3 మీటర్స్లో అయిపోయింది. లైన్లో 6 మీటర్స్ కావాలి, 3 మీటర్స్ కావాలి. అదే లైన్లో మనకు పాయింట్లు కావాలి. ఆ పాయింట్లన్నీ మనం ఎస్ఓ లైన్లోకి వెళ్ళి అదే ఆఫ్సెట్లో పెట్టచ్చు. సేమ్ నాకు ఆఫ్సెట్ 0 ఉంది. ఆఫ్సెట్ 0 ఉంది అంటే N1 దగ్గర. దాని నుంచి 90లో కావాలి ఆఫ్సెట్. 90లో కావాలంటే 2 పాయింట్ని బేస్ చేసుకొని 90లో -2 మీటర్స్ అంటే -2 మీటర్స్ వస్తుంది. అదే మనం అటుపక్క పెట్టాలంటే +2 మీటర్ అంతే. ఇట్లాగా ఎస్ఓ లైన్ ఉంటుంది అన్నమాట. దీని టోటల్ స్టేషన్స్ ఇన్ని వర్కులు చేయొచ్చు.